black holes are the most powerful things in the universe, strong enough to rip whole stars into atom-sized pieces. In fact, we're seeing these tidal forces in action right now in our own galaxy. An elongated cloud of gas called X7 is swooping dangerously close to the Milky Way's central supermassive black hole. Over 20 years of observations, astronomers have witnessed X7 stretch dramatically as gravitational forces pull it apart. It's a perfect example of how black holes can spaghettify nearby objects. But what makes black holes even more perplexing is they may even eventually delete the universe itself. Let's dive deeper into why. At their core, black holes form when extraordinary amounts of matter get concentrated into tiny spaces. The gravity becomes nearly infinite, shredding anything that gets too close. Not even light can escape, which is why we see them as dark spheres. Falling into a black hole is like passing the point of no return over a massive waterfall. But black holes aren't completely cut off. They shed mass slowly via Hawking radiation over trillions of years. Eventually, they may evaporate completely in bursts of energy. Here's the puzzle. This disappearance could violate a fundamental law, the conservation of information. You see, information distinguishes particles and energy based on their arrangement. What makes a turtle different from a lemon is the information encoded in their particles. Quantum theory says information can't be destroyed, only transformed. But if black holes vanish totally, they could be erasing information from the universe. This violation launched the famous black hole information paradox that has stumped physicists for decades. How can we resolve it? Perhaps information is stored in strange quantum dimensions or black hole remnants, but that's not very useful if we can't access it. The most exciting possibility is information gets encoded on the boundary, just like throwing rocks in a pond. This is called the holographic principle. It implies we live in a hologram projected from a distant flat surface. Incredibly weird. The universe is profoundly mysterious, but black holes with their extreme gravity may contain keys to understanding reality's deepest secrets. We have much more physics to do before unlocking their puzzle. It makes me feel pretty small and fragile out here in the suburbs of the Milky Way. Reminds me how lucky we are that the supermassive black hole at our galactic center is sleeping so soundly. But also, concepts like tidal forces are pretty abstract. Being able to see their effects across just a few decades of observations makes them much more visceral and real. So I'm thankful to have such an extreme example like X7 to better understand the hidden engines constantly shaping our stellar ecosystem. Big thanks to the researchers for undertaking such a marathon observing campaign and piecing together this cosmic puzzle. All right, everyone, that wraps up this astronomy update. Let me know in the comments if you have any questions about X7 or the mighty forces around our galaxy's central black hole. And don't forget to like and subscribe to stay up to date on more mind-bending topics. I'll see you later.